One. Greetings and welcome, friends. We're taking a look at last night's quest starting on page 23. It was actually our second time working on this page, but it was a good batch of problems here, I'd say so myself. We're still solving equations using our algebra skills to isolate variables, and in this instance, we had variables on both sides of the equal sign. So step one we do is simplify, which means distribute, combine like terms. In this case, looks like there's some distributing to take place. Oh, this one's going to be, right here. I bet I almost have, over 50% of students, I bet, will have made this error, not including the minus sign with the distribution. Super common area for a mistake. 2 times 4x, 8x, 2 times positive 2, positive 4, equals 4x. And now check this, negative 12x. And negative 12 times negative 1 is positive 12. So this sign right here has massive potential for mistakes. So check to make sure that you've got that right there. When you distribute, it does include the sign in front of the number that's being multiplied by the set of parentheses. Let's go through combine like terms. Remember, I can only combine terms that are on the same side of the equal sign. Like terms have the same variable and exponent, and when I combine them, I just simply add their coefficients, or the numbers in front of them, when they are variables. Let's see, so 4x and minus 12x, or 4x plus negative 12x, signs are different, so I'll subtract. 12 minus 4 is 8. Still in x's. Which one was more influential? Looks like the 12, so it stays negative. Oh, yeah, okay. I thought it was going to be one of those ones where it was going to be no solution or infinitely many solutions, but no, that would have only worked if both of these were positive. Now we've got it simplified. I still have variables on both sides. My trick is to move the little guy to the big guy. Negative 8 is littler. You're not wrong if you try to move the positive 8x. It'll still work out. You're just going to have a different route, and that's fine. That's absolutely fine. 16x plus 4 equals 12. Now to solve for 16, let's use some inverse operations. It's being multiplied by 16 and added by 4. We got to deal in addition first, because SADMEP, we reverse order of operations as we diffuse this bomb, right? I've got to kind of do it in the reverse way that it was constructed as I disassemble. 12 minus 4 is 8. 16 is being multiplied by x, so I divide both sides by 16, and I'm going to get x equals, I can reduce this fraction. What goes into both 8 and 16? What's a number? 8 does. And even if you didn't know 8 did, you could be like, hey, they're both even. Let me just divide both of those by 2, and then you divide by 2 again and again. But yeah, if I just notice that 8 goes into 8 once and 8 goes into 16 twice, that's the speediest way, the el más rápido del mundo way to reduce that problem. So I get x equals 1/2, perfectly fine number. Fractions exist, so I'm guessing that's the solution. If I wanted to do a check, I'd actually have to plug 1/2 in for all of the x's in the original problem, and then do it in PEMDAS order to see if both sides are still equal. All right, so actually, yeah, I was going to move on, but I'll summarize this. So these first 2 steps were simplify. This step was bring little guy to big guy. All right. And then these last steps were reverse PEMDAS, right? Isolate the variable, using kind of SADMEP. All right, so for the problems you guys are doing, this is in general going to be the route that you take for all the problems. The earlier problems on the quiz will not include this step and this step. All right. Later problems on the quiz might include a simplify step, but maybe all the variables were on one side. So after you simplify, you do that. Some problems will be like this, where you just start here and then do that. And then the most complicated problems are like this question 16 that has simplify, bringing the little guy to the big guy, and then solving using SADMAP. All right, so that's kind of like all the concepts together, but this is always the sequence in which you do it. All right, let's take a look at another problem here. Question 17, modeling with mathematics. Now, math is the language of the universe. We can use it to describe all sorts of motion, behavior, growth, all sorts of things within our universe. It's the way we understand things. It's the language of the sciences. So when we model with mathematics, that's when I'm taking a real-world situation and then representing it with an equation or expression or things like that. So here it says, you and your friend drive toward each other. The equation 50h equals 190 minus 45h represents the number h of hours until you and your friend meet. When will you meet? Now, interesting. So it appears as though in this problem, it's related to the equation rate times time equals distance. They didn't tell you all that. And over here could be, say, your rate times time. So h was in hours. Let's say 50 was like 50 miles an hour. You didn't have to know all this to solve the problem. You could have just solved the equation. And for your friend, he's traveling, right, 45 miles per hour multiplied by the number of hours. And then there's this additional factor of 190 where maybe you guys started 190 miles apart from each other. And we're interested in when those two things will be equal. Graphically, later we'll actually represent this as one line and this as another, and we'll find the intersection between those two things. But in this case, today, let's just solve the equation. So 50h equals 190 minus 45h. Step one, what should I do? What's my first move, you guys think? Yeah, bring the variables together. So little guy is negative 45 compared to 50, so we'll add 45 and make sure we throw an h in there. That's 45 h's that we're moving, not just 45. So let's see, so this looks like it's going to be 95h equals 190. And now h is being multiplied by 95. How do I solve for h? Divide both sides by 95. Right? So I'm going to get h equals, is it just 2 exact?
Not too exact.
Well, let's see, 90 times 2 would have been 180, and then 5 times 2 is another 10. Yeah, I think it is 2 exactly, huh? And they asked the question, when will you meet? So let's translate this. H was measured in hours, they told us. So let's say you will meet in 2 hours, right? So we can communicate. We mathematicians don't have to just say h equals 2 and just be all robotic about it. We can be a little bit human here and share, right, in language other than the language of mathematics. All right, last question. This question was asking, is there one solution, infinitely many solutions, or no solution to the problem? All right, now this problem could have shown up in the form of just saying solve, and then if we had, realized there was a problem as we're solving, we would then have to discern, like, okay, there's not just one solution here, there's something else going on. So we're going to still try solving this using our normal strategy. So step one, let's do some distribution. 3 times 4g is 12g. 3 times 6 is positive 18, plus 18, right? 2 times 6g is 12g, and 2 times positive 9 is plus 18. Uh-oh, redundancy here. When I try to bring my g's together, there is no little guy, there is no big guy, and then I'm like, minus 12g from both sides. What's going to happen? Oh, man, they just like, whoosh, 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 and those just like zero out on me here, and I just get 18 equals 18. Now, is 18 equal 18 a true or a false statement? True. And because it's a true statement and I no longer have a variable, I never found like G equals something, and my variables disappeared, the way we analyze this outcome is we say that there are infinitely many solutions. You can also say it this way. You can say all real numbers. All right, so like any number that's real that you can think of is a solution to this equation. And that would suggest that someday there might be numbers that are not real. We'll talk about those some days. Maybe in Algebra 2, actually. Algebra 2. So yeah, so that's how we would classify that problem. I'm fine with either way of wording it. I think I've even seen something like this, G equals G sometimes, where it's just like G is equal to anything you can think of. Yeah, but anyways, thanks for watching, internet friends. Have a great day. La la la.